welcome to this explainer. Today, we're diving right into how 21st century science is finally solving literally the greatest archaeological jigsaw puzzle ever found, the Dead Sea Scrolls. For decades, these ancient texts have guarded their secrets so closely, but today, we are going to explore the cutting-edge technology that is changing absolutely everything we thought we knew about them.
Now, you might be wondering, what's with that massive 25,000 number? Well, here's the thing. When we hear the word scroll, we naturally picture this pristine, beautifully rolled up document, right? But the reality is that the famous Dead Sea Scrolls aren't mostly scrolls at all. Researchers are actually dealing with 25,000 tattered, decaying, and scattered fragments. It's a real mess.
So here is our forensic toolkit for today. We'll start with Section 1, the ultimate ancient jigsaw puzzle. Then Section 2, seeing the invisible with light. Section 3, decoding fragments with ancient DNA. Section 4, AI identifies the anonymous scribes. And finally, Section 5, redefining ancient scribal culture.
All right, let's jump right into Section 1, the ultimate ancient jigsaw puzzle, and take a look at decades of decay and mishandling.
Just imagine having to manually sort thousands of tiny, crumbling pieces on long tables, exactly like they did back in the 1950s at the Rockefeller Museum. It was, literally, the world's most difficult jigsaw puzzle. But today, we've swapped out the naked eye for heavily calibrated, modern spectral imaging labs. We've totally moved away from human guesswork and are now relying on highly advanced digital sensors. It's a real game changer.
And the reason the technological leap is so critically important is because, well, we have to remember the context of the early discovery. Before modern conservation techniques were a thing, early scholars actually accidentally accelerated the decay of these fragments. It's hard to believe, but well-meaning researchers used materials like pressure-sensitive Scotch tape, castor oil, and even acrylic adhesives to hold pieces together. This unintentional mishandling over 4 decades made modern, completely non-invasive intervention an absolute necessity just to stop the scrolls from being lost forever.
Moving right along to Section 2, seeing the invisible with light, using the Megavision Multispectral Imaging System.
So, to preserve the scrolls without touching them any further, the Israel Antiquities Authority uses a rigorous, highly specific process. First, they take 28 separate exposures per side of a single fragment. They hit the parchment with 12 different wavelengths of light, spanning both the visible and near-infrared spectrums. Then they use raking light from the side to map the physical topography, the actual bumps and grooves of the ancient leather. Finally, they digitally stitch these massive files together, merging them to create a perfect digital replica. And the best part? They do all this without ever having to physically touch the fragile fragment again.
Here is the really crucial point. Carbon-based ancient ink absorbs near-infrared light. So what normally looks like a blank, blackened, completely unreadable scrap to the naked human eye, suddenly yields crisp, readable Hebrew text. This system is literally revealing text that has been completely invisible to the world for centuries. How amazing is that?
This technology doesn't just preserve the physical condition of the fragments, though. It actually recovers lost content. By bypassing those decades of dark decay, scholars are suddenly reading fragments that were previously considered completely lost or just too damaged to decipher. In one incredible recent example, this imaging allowed a scholar to recover a completely missing word in Psalm 147. It revealed that the ancient version was actually one word shorter than the version we thought we knew. Just wild.
Okay, let's look at Section 3, decoding fragments with ancient DNA, or what we call the biological fingerprint.
I absolutely love this perspective from biblical scholar Noah Mizrahi. He points out that the biological material of the texts, the actual stuff the texts are written on, is as informative and as telling as the text that was written on it. Because these scrolls were written on animal hides, the very parchment holds deep genetic secrets about exactly where these texts came from.
By using deep sequencing DNA technology to amplify tiny bits of animal DNA extracted from the scrolls, scientists made a fascinating discovery. They found that while the vast majority of the scrolls were written on sheepskin, which, makes perfect sense for the local arid Qumran area, a very rare few were written on cowhide. So why does this matter? Well, the Judean desert simply lacked the grass necessary to raise cattle. This proves definitively that those specific cowhide scrolls had to be brought in from outside the region.
And this brilliantly solves a major puzzle regarding the book of Jeremiah. For years, scholars looked at the texts on 2 specific fragments and just assumed they belonged together as part of the exact same scroll. But DNA testing proved one fragment is cowhide and the other is sheepskin. There is no way they could possibly be from the same scroll. This genetic evidence revealed they actually represent two entirely different versions of the prophetic book that were circulating at the exact same time.
Next up is Section 4. AI identifies the anonymous scribes, where we are cracking the code of the Great Isaiah Scroll.
Now, the Great Isaiah Scroll is a true historical masterpiece. It features 54 columns of text spanning a mass of 7.34 meters in length. And to the human eye, the handwriting across this entire document looks completely uniform. For decades, scholars logically assumed this incredible manuscript was the painstaking work of a single, highly skilled scribe.
But computers can see what we can't. By feeding highly contrasted digital images of the ink traces into an AI, researchers analyzed what they call fraglets and hinges. These are microscopic data points that measure the exact subconscious muscle movements of the ancient writer's hand. The AI looks at how the scribes slowed down their pen to make a curve, the exact angles of the ink traces, and those tiny biomechanical quirks that are unique to every single human being.
What the AI discovered completely upended our understanding of this scroll. The algorithm found a clear phase transition right at column 27. It mathematically mapped the handwriting into two distinct statistical zones. The variance level is totally different between the first half and the second half. This proves, without a shadow of a doubt, that there were actually two distinct scribes who shared a nearly identical visual style, splitting the work right down the middle.
Finally, we arrive at Section 5, redefining ancient scribal culture, going from puzzle pieces to human history. So the major takeaway you should have from this explainer is that ancient texts were highly dynamic. They weren't rigidly fixed, different versions existed, and were subject to continuous revision and interpretation. We now know, thanks to AI, that anonymous scribes actively collaborated side by side, expertly mirroring each other perfectly while editing the foundational text of the ancient world. And thanks to DNA, we know for sure that reading the biological materials is just as important as reading the ink.
As we wrap up this explainer, I want to leave you with this final thought. If light, DNA, and artificial intelligence can fundamentally change our understanding of the most famous archaeological discovery of the 20th century, what other ancient mysteries are just waiting out there for the right forensic tool to crack them wide open? Thank you so much for joining me on this deep dive into the Dead Sea Scrolls.